How do solar panels, now an important source of green energy, convert light into electricity? How does it work? Here's the answer. In order to use solar energy, we need to use sand as raw material. Firstly, the sand is refined into 99.999% pure silicon crystal. The sand is converted into raw silicon after complex commission. And then the raw silicon is converted into gaseous silicon compounds, and then mixed with hydrogen to obtain high-purity polygold silicon. Polysilicon is cut into very thin silicon wafers, which are the heart of photovoltaic cells. At this point, the silicon atoms in the wafer are firmly bound together, with no electrons in them free to move. If a phosphorus atom with a fifth order electron is injected into a silicon crystal, one of the electrons on the phosphorus atom can move freely. When sunlight hits the material, the free electrons inside gain the energy of photons, and their irregular free motion intensifies. But it cannot yet generate an electric current in any load, because electric currents can only be generated by the directional motion of electrons, which requires a driving force. This can be done through a p-n junction. We inject boron with third-order electrons into pure silicon, and each boron atom creates a hole. If the two mixed materials are joined together, the n-type electrons will go into p-type holes, and the region formed near their junction is called a p-n junction, resulting in a slightly positive charge on the n-type side and a slightly negative charge on the p-type side. An electric field is formed between these charges. When light hits the n-type region and penetrates through the depletion layer, photon energy creates electron hole pairs in the depletion region, and the electric field in the depletion region drives the electron hole pairs to the sides. So the concentration of electron holes in the n-type and p-type regions gets higher and higher, so that when we connect the two regions, the load generates voltage and generates current. So solar electrons provide direct current. The top layer of the cross-section of solar panels is very thin and heavily doped. The underlying p-type layer is thick and lightly doped, which improves the battery's performance. This creates a thicker depletion layer, which means that absorbing light creates small pairs of electron holes, and thus more current. Another advantage of this structure is that the top layer is thinner, allowing more light to pass through and reach the depletion layer, making power generation more efficient. The solar electromagnetic panel consists of many layers, one of which is the battery layer. Electrons on the battery surface are collected in the bus bar after passing through the sublines. The surface of the battery is a negative electrode, which is connected to the back of the next battery with copper strips, and these batteries are connected in series to form a large plate. So many solar panels can increase the voltage and current to the usable range. EVA film layers on both sides of the battery protect the battery from shock and moisture. Do you understand how solar panels convert light into electricity?